Hi guys, how are you? I hope you people are doing well. My name is Shivam Pandey and I'm your geography mentor. So guys, in today's session we will talk about the origin of the universe and the earth. We will come to know about in this section that how our universe was formed, how the origin of the earth took place. So let's get into the interesting session of today's. Okay. So in yesterday's class, I had talked about the some scientific concept with you people, and those scientific concepts were like that. Let me remind you people about those particular scientific concepts, and those concepts are like that. We have talked about the kinetic theory of gases. In that particular thing, we had talked about that molecules are arranged in themselves on the basis of their stage of matter. That is, in solid, molecules are tightly packed, in liquid, molecules are loosely packed, and in gases, the molecules are apart from each other. And second scientific concept was that in that particular thing, we talked about a particular thing that was this that these particular molecules are always in the random motion, and that random motion is known as the Brownian motion. Next scientific concept was that the third scientific concept that we talked in our yesterday's class, and that was the thing that every moving object has its own velocity or the energy, that is the kinetic energy, and kinetic energy is equals to half mv square. If molecules get collided with each other, then there will be the reduction in velocity. And guys, according to the law of conservation of energy, it says that energy can't be created nor be destroyed, it is transferred from one form to another form. So according to this thing, if molecules are in Brownian motion, in random motion, they are having the certain velocity in them, and due to this velocity they will get collided with each other. When they will get collide with each other, there will be the reduction in their velocity, and the reduction in velocity will increase or will transfer in some another form of energy, and that particular form of energy is known as the latent heat or the enthalpy. In scientific term or in geographical term, we say this latent heat as the enthalpy. So this was the thing that we had talked in our yesterday's class. So guys, now in today's section we're going to talk about the origin of the earth or the Big Bang theory. Okay, let's continue from the Big Bang theory. The Big Bang theory. Guys, remember one thing. In yesterday's class, I had told you that around 13.8 billion years ago, there was no universe, no galaxy, no solar system, no planets were there. There only exists a huge mass of matter, and that particular piece of matter is known as the primordial matter. And primordial means that the event that took place before the formation of the universe. Okay, there only exists a primordial matter, and the source of that particular primordial matter was unknown to us. So the Big Bang theory was given by Edwin Hubble in 1923 and in 1924. So according to Edwin Hubble, this primordial matter, or according to NASA, this primordial matter was in its plasmic stage. Plasma is the fourth stage of matter. Matter has its five stages: solid, liquid, gas, plasma, and Bose-Einstein condensate. After this thing, I have told you that in plasma, or in yesterday's class, I had told you about the thing that plasmic stage is not naturally found over the earth. Plasmic stage is achieved when gases are highly compressed. So guys, according to this thing, when gases are highly compressed, then plasmic stage is achieved. And naturally, upon the earth, the plasmic state could not be achieved. So plasmic stage is achieved only in the celestial body, in the outer space. So in that case, the primordial matter, this was the primordial matter, and this primordial matter this primordial matter was in the fourth stage of matter. Fourth stage of matter. And that particular fourth stage of matter is the plasma. After this, guys, in this fourth stage of matter, the molecules in plasma, the molecules are even tightly packed than solid. Okay, the intermolecular space in plasmic stage is very low, very low. Okay, in the plasmic stage, the intermolecular space in the plasmic stage is very low. Due to this, guys, the molecules are always in random motion. We have talked about this thing in yesterday's class. So molecules are always in random motion like this. Molecules are always in the random motion. And when they are in random motion, they will get collided with each other. And due to the collision, there will be the decrease in the velocity of these molecules of the primordial matter. And when molecules get collided with each other, there will be the generation of enthalpy. Why? Because there will be the reduction of kinetic energy, there will be the reduction of velocity, and due to the reduction in velocity, there will be the generation of enthalpy, and enthalpy is known as the latent heat. And at a particular time period, this enthalpy will be at its peak. The latent heat will be generated in a humongous amount that this primordial matter will burst. And this particular event is came to known as the Big Bang. This particular event is known as the bang. This primordial matter will explode into small pieces. It will get fragmented into small pieces. Explode into small pieces, and these pieces were like this. And remember one thing, these are the pieces of primordial matter. So this particular thing is also in the fourth stage of matter, that is the plasma, and here is the formation of the universe. And here will be the formation of the universe. Universe formation will took place. And guys, these small pieces are known as supernova or the mini primordial matter. They are known as the supernova. These universe or these mini primordial matters are known as supernova. So what happened here? Here nothing was happened. Here exists a huge mass of matter whose source is still unknown. Even NASA don't know that from where this particular primordial matter came. But this primordial matter was in a huge amount, was in a huge size, in a humongous size. So it was in the fourth stage. In fourth stage, molecules get collided with each other because there are zillions of molecules, and these zillions of molecules are getting collided with each other. And due to the collision of these particular molecules, there is the reduction in the velocity, and the reduction in velocity will leads to the formation of latent heat. And at a particular time period, this latent heat will generated in a huge amount. Due to this primordial matter will get exploded into the small pieces, and these particular pieces are known as the universe or are known as the supernova. So these are the things that we should know about first. And guys, remember one thing, this universe is a rotating structure. These universe or the supernova are the rotating structure. Why, guys, they are the rotating structure? Because if you see that mass is inversely proportional to velocity. If the mass is high, then velocity will be low. If velocity is high, then mass will be low. And the mass of this primordial matter was very huge, very much. The mass was very high. When it gets fragmented into small pieces, then mass is distributed among these small pieces. That's why we could see the rotation in this particular mini primordial matter or in the supernovas. After this, guys, what happened? This supernova is made up of plasma, which is the fourth stage. We know that in plasma, molecules are very tightly packed, and the molecules are always in random motion, and molecules are doing the random motion in this plasmic stage. When molecules are doing the random motion in this particular plasmic stage, then there will be the reduction in velocity, and the reduction in velocity will lead to the generation of enthalpy. And when there will be the generation of enthalpy, this particular supernova or the mini primordial matter get fragmented or get again exploded into small pieces. And this particular thing is known as the second bang. The first bang formed the universe, and the second bang formed the solar system. So these solar systems are the rotating structure. Okay, so they are known as solar system or nebulas. They are the nebulas, and they are the solar system. So are we good about these particular thing, guys? Okay. So are we good about these things? So here is the formation of the supernova and nebula, and so you can say that the formation of solar system. Guys, remember one thing, that the second bang which happened from this to this, it is known as the second bang. And guys, second bang happened around 7 to 8 billion years ago. 7 to 8 billion years ago. This was that happened. Okay, remember these things. These are very important for our exam point of view. So these are the certain things. Are we good about these things? So please let me know in the comment section that are we good about these things or not. If you have any doubt, then please let me know that you have this kind of doubt in particular thing. So please let me know in the comment box. Okay, let's move towards the next stage. After Big Bang, we have to talk about the second stage, that is the protoplanet hypothesis. Guys, when we talk about protoplanet hypothesis tells us about the story from where? From it continues the story after the Big Bang theory. Big Bang theory ends here only. And from here, the protoplanet hypothesis continues. So we have the formation of solar system. So according to the protoplanet hypothesis, protoplanet hypothesis, it was given around 6 billion years ago. Now guys, according to this particular thing, according to protoplanet hypothesis, the nebula was formed. According to this, the nebula was formed, and this particular nebula was in a disc-like structure. It was a disc-like disc-like structure. Guys, I guess you people have played the frisbee. Like, see my palm. The structure of the nebula was like our palm. It was in an oval shape, or you can say that its shape was a circular shape. The nebula look this, like this, and there are lot many molecules in this particular nebula. Okay, it has many molecules in itself. It contains the many molecules. It's a 3D diagram. You have to imagine this particular diagram, and it has a lot many molecules in itself. Okay, so these are the different molecules. And guys, remember one thing, this nebula is a rotating structure. Okay, nebula is the rotating structure. It is moving like this. It's a rotating structure. Okay, now when we talk about this particular thing, so remember one thing, it's a circular motion, so force will act upon them. Okay, so there it is rotating like this, so two forces will act upon them. These are the molecules. Nebula is a rotating structure due to which two force will act upon them. Okay, so these are the things. And what are those particular forces? We have the centripetal force and we have the centrifugal. Now, what is the centripetal and centrifugal force? You people might heard about this particular forces, centripetal and centrifugal force. If any rotating object is observing these forces, if any object is rotating, that particular object is facing the centripetal and centrifugal force. Let me explain these particular forces to you people by giving a certain example. Now, guys, have you ever seen, have you ever gone to the fair and there we have, or let it be, let's take another example, like we people have always played a game when we were kid. At that time, we have tied a knot upon a stone and we have rotated that stone in a circular direction. The force which is acting inward inside towards our finger, from stone towards the finger, that particular force is known as the centripetal force, and the force that is exerting outward from our finger towards the that particular stone, when we are rotating that stone, the force that is acting from the center or from the from our finger towards that particular stone, that particular force is known as centrifugal force. So centripetal force is an inward force that is acting inward side, and centrifugal is a outward force. When we play a game with our friends, like if you hold the hand of your friend and you both rotate in a circular direction, then you will lean your body outward like this and your legs will be inside. So here the centripetal and centrifugal force will act. Okay, so these are the things. Now guys, when we talk about these certain things, we should know one thing. Now, what are those particular things? Hi, Jai Hind, how are you? Okay, when we are seeing this particular thing, then the force will act, and the force that will act towards the center, and the force will act towards the center. So this particular force which is acting towards the center is the centripetal force. Okay, so this force will act towards the center. This is the centripetal force. Centripetal force. And guys, due to the centripetal force, these molecules will get accumulated at the center. There will be the dense molecular arrangement at the center of the nebula. And this particular dense molecular arrangement at the center is known as the protostar. This particular thing. So how our solar system will look like from here? Let me draw the things. Okay. The dense molecular arrangement will be at the center like this. This is the dense plasma structure. Okay. The molecules get accumulated at the center of the solar system due to the centripetal force. And guys, after this thing, when molecules get collided or when molecules get accumulated at the center, and at the center there will be 1% of volume and 99% of mass. At center we have 1% of volume and 99% mass. At the center we have the dense plasma accumulation. Dense plasma accumulation will be at the center. So we have seen this particular thing, and this particular structure or this particular thing is known as the protostar. This dense plasma accumulation at center is known as the protostar. And guys, you know that our protostar is the sun. So our protostar is sun. So here is the formation of sun took place. So are we good about these particular things? If we are good about this thing, please let me know in the comment section, or if you have any doubt, then please let me know about these things. Now guys, when molecules get accumulated in the center, this means that there are still some molecules that are rotating here also, but the number of molecules is very low. But molecules are also there. In the vacant space, there would be the 1% of mass. Here will be 1% mass and 99% will be the volume. Okay, vacant space. Now guys, these molecules will be also rotating. These molecules are also rotating with this particular solar system. Now guys, what would happen here? Remember one thing. Here we have the molecules of iron, oxygen, hydrogen, water vapor, carbon dioxide, okay, helium, argon. Lot many molecules are there. Many molecules are there. These molecules are having different mass. The masses of these particular molecules will be different, and we have heard about a thing that mass is inversely proportional to velocity. What we have heard? We have heard that, sir, mass is inversely proportional to velocity. Due to this particular formula, due to this particular thing, these different molecules have their different velocity because their masses are different from each other. The iron molecule have low velocity as compared to the helium molecule, as compared to the oxygen molecule, because there's a difference between their masses. So when these molecules are also rotating, these molecules will also get combined with each other due to the two forces. There are two binding forces. There are two binding forces which act upon the molecules. That are the cohesive and adhesive forces. Cohesive and adhesive forces are the binding force over the molecules. So what happened here when we talk about the cohesive and adhesive forces? Now, remember one thing. When we talk about the cohesive and adhesive forces, what happened? Remember one thing. We have two binding forces upon the molecules, and they are the cohesive and adhesive force. They are the cohesive and adhesive force. Now guys, when we talk about the cohesive and adhesive force act upon the same molecules. Cohesive force always act upon the same molecules, and adhesive force act upon the different molecules. They act upon the different molecules. How? We have always done a thing in our childhood that we have taken a drop of water, we have put a drop of water over our hand, and we had tried to put another drop of water over the same drop of water. So the binding force upon those two water droplets was the cohesive force, because the water droplets are having the same molecules. When we combine that particular water droplet with our cloth or with our skin, then the molecules are different. So the binding force upon them would be of the different molecules. So the binding force would be the adhesive force at that time. Okay. Now guys, next. When we talk about the next thing, we have to look into the things like that. Guys, whenever these molecules get combined with each other, when molecules are getting combined with each other, they always try to take a shape, and they always try to take a that shape which shape takes the minimal surface area. And you people know that sphere is the only shape, or circular shape is the only shape that takes the minimal surface area. So these molecules are rotating. Okay. What would be the image? Image would be like this. These particular molecules are rotating structure. We have the nebula. Nebula is rotating structure. And we have the dense plasma or the protostar in the center like this. Okay. Due to this, we have the different molecules like argon, helium, carbon dioxide, oxygen, nitrogen, water vapor, iron. Okay, many different molecules are there. And when they are also having the different velocity because of their different masses. Their mass is different. The molecule of iron is weighted and the molecule of helium is in the light in weight. So the velocity of helium molecule will be always higher than the iron molecules. Why, sir? Because mass is inversely proportional to velocity. Guys, after this particular thing, after this, what would happen? These molecules get started moving, okay, in a circular direction because it is rotating. And when they get combined with each other, they try to take a shape, and that shape which take the minimal surface area. So by rotating, when they get combined with each other, they achieve their spherical shape and they get converted into the planets. So here the formation of planets took place. Okay, here the formation of planets took place. So are we good about these particular things? Are we good about these things? Please let me know in the comment section. Okay, now guys, let's move towards the next question. Now guys, after this, what we have talked till now? Sir, we have talked about the primordial matter, how primordial matter get converted into the universe and then the nebula, and after that how the formation of protostar took place. Up till now, here we have talked about, here up till now we had talked about these things. Okay, how the formation of nebula took place, and after this we had talked about the formation of the planets. Okay, so these are the things. Now let's move towards the third part of the story, and that particular third part is the Kant's gaseous hypothesis. So we have to talk about the Kant's gaseous hypothesis. Remember one thing, guys. Remember one thing. These planets are the revolving structure. These planets are the revolving structure. So what happened here? Here nothing happened. Rotating nebula was there. Let me recall the things. Rotating nebula was there. Rotating nebula was there. This particular rotating nebula, due to this rotating nebula, centripetal force act upon them. Which force? Centripetal. Centripetal force act upon them. Now guys, due to the action of the centripetal force, there will be the mass displacement. There will be the mass displacement. And when mass get displaced from here, mass get displaced due to the two region, mass get displaces into the central region. This particular mass get displaced in the central region. When we talk about this particular thing, here we have the dense plasma. Dense plasma structure. Guys, this dense plasma structure is commonly known as the protostar or the sun, formation of protostar or the sun. Okay, so these are the things. After this, there was the gaseous molecules. There was the gaseous molecules, and in these gaseous molecules they are having the varying density. They also have the adhesive, the force that act upon them will be the adhesive and cohesive force will act upon them. And cohesive force will act upon them. After this, they will get converted into the spherical shape and there would be the formation of planets. Okay. So are we good about these particular things? Now guys, let's talk about the protoplanet let's talk about the Kant's gaseous hypothesis, that is the stage 3. Kant's gaseous hypothesis, stage 3. Guys, remember one thing, according to protoplanet hypothesis, Earth was originally in the gaseous sphere around 4.6 billion years ago. According to, remember one thing, according to protoplanet hypothesis, the Earth was in gaseous state. The Earth was in gaseous state around 4.6 billion years ago. Okay. And one thing more, guys, this Kant's gaseous hypothesis tells us about the thing that how the formation of lithosphere, hydrosphere, and atmosphere took place. So it tells us that how land, water, and air was formed. Okay. So till the end of this particular theory, we will came to know that how land, water, and air was formed. Okay. So let's get into this particular thing. So according to the protoplanet hypothesis, 4.6 billion years ago, Earth was formed. Now guys, when Earth was formed around 4.6 billion years ago, Earth was in the gaseous state. And the temperature of the Earth was around, in this particular time, the temperature of the Earth was very, very, very high. The temperatures of the Earth was around somewhere you may say that it was around 2 lakh degrees Celsius. The temperatures were around 2 lakh degree Celsius, around 3.8 billion years, 4.6 billion years ago. Temperatures were 2 lakh degrees Celsius. So everything over the earth was in the vaporized form. Everything over the surface of the earth was in the gaseous form, because these temperatures are really very, very, very high. Earth was in its static position from 4.6 billion years to 3.8 billion years ago. Earth was in its gaseous form, and Earth was doing the process of radiation. Earth was doing the process of radiation. So what does radiation means? Radiation means the liberation of heat in the outer atmosphere. So Earth was liberating its heat in the outer atmosphere. Earth was liberating its all heat in the outer atmosphere, like this. This is the outer atmosphere. So Earth was liberating the heat in the outer atmosphere. It is the process by which Earth was liberating the heat in outer space. In outer space. So radiation is this kind of process. Remember this thing. Okay. Now guys, after this is the process of radiation. Now guys, from 4.6 billion to 3.8 billion years, Earth was liberating its heat. Now remember one thing. Around 3.8 billion years ago, the average temperature, not the average temperature, the temperature of the Earth was around 2000 degree Celsius. Because Earth was liberating heat, so from 2 lakh degree Celsius, the temperature fall down till 2000 degree Celsius. And many things have achieved their liquid stage. So around 3.8 billion years ago, Earth was in its liquid stage, like iron, copper, aluminium. Many things were there which have achieved their liquid stage. But still, some substances were there which have not achieved their liquid form. They were still in the gaseous form. What are those substances? Those substances are like nitrogen, oxygen, carbon dioxide, water vapor, because for them the temperatures are still very high. For them, the temperature is still very high. 2000 degrees Celsius is not a low temperature. But the highest boiling point is of the iron. And the highest boiling point of iron is that around 8000 degrees Celsius. But the temperatures were 2000 degrees Celsius. So iron was in its liquid stage at that particular point of time. But these many substances were in the gaseous form and few substances were in the liquid form because the temperatures were low at that particular point of time. So guys, what happened? When we see our earth, these few substances are in gaseous form and few of them are in the liquid stage. Like this is the earth. So earth was in the gaseous form, or the earth is in the liquid stage. This is the liquid earth. Liquid earth. In geography, guys, we'll always see the two view. We will see the front view and we will able to see the side view. We will see the front view and we will able to see the side view. Now guys, when we see these things, the density of these liquid like iron and like other thing, the density of these particular substance is high, like iron, like aluminium, like copper, nickel. The density of these substances is high. So guys, at that time, the substances like nitrogen, carbon dioxide, water vapor, they are having the low density. So due to the low density, these substances started rising upward direction. Okay, these substances started rising in the upward direction because their density is low as compared to the liquid substances. Have you ever boiled a water? When bubble come out from that particular water, the gases are escaping from that particular bubbles. So earth was looking like that particular boiling water. The gases were escaping out because they were having the lower density, and due to the lower density, these gases were escaping out, and this particular process is known as degassing. So the process of degassing was happening. Degassing process. Why? Because gases were having the low density and liquid substances like iron, aluminium, copper, magnesium, okay, and nickel, many substances are there. Liquid substances were having high density. High density. Now guys, these gases were started moving in upward direction. But guys, their rising velocity is lower than the escape velocity. The rising velocity of these particular substances, the rising velocity is less than the escape velocity. Okay, the rising velocity is less than the escape velocity of the earth. Due to this, guys, due to this particular thing, They reach the certain height and they get trapped there only. They reached at the certain height and gravity started pulling those particular gaseous substance towards itself, and they do not able to escape the earth's earth. They do not able to escape the earth. So they get trapped into the upper layer of the earth, which is commonly known as the atmosphere, and hence when these gases get trapped at a certain height, they form the atmosphere. And remember one thing, that gravity is pulling them towards itself. That's why atmosphere is there. This is the gravitational force. Gravitational force is pulling these gases towards downward direction. Towards downward direction. Clear? So are we good about this particular thing? Now guys, after this, when this particular gas get trapped into the upper layer of the earth's surface, so this particular thing form the atmosphere. And what is the escape velocity? Guys, escape velocity is the velocity by if we throw an object with the particular speed, that is 11.2 kilometers per second, then that particular object will go in the space. Okay, the speed should be 11.2 kilometers per second. So this is the escape velocity. Okay, so these are the things. So this is how the atmosphere took place. The formation of atmosphere took place. So are we good about these particular things? Now guys, let's talk about next thing. Let's talk about how the formation of lithosphere took place. Now guys, we have seen that we have our earth. Earth was there. The formation of the earth was there like that. And after this, we have seen that we have the outer atmosphere. This was the atmosphere. This was the atmosphere. And remember one thing, these gases, these gases were at this particular time, the atmosphere and the earth was still doing a process, and that particular process is known as the radiation. Still, both the earth and the atmosphere was doing the process of radiation after the formation of the atmosphere. This is the process of radiation. This is the process of radiation. Now guys, after this particular thing, when we talk about these things, remember one thing, and that particular thing is that when we talk about these particular thing, we have the major substances which have created the substances of the earth. We have the major substances, that have created the surface of the earth. We have the major substances which have created the surface of the earth. Now, what are the those what are those substances? Those substances are like silica. After silica, aluminium, magnesium. Okay, silica, aluminium. Okay, aluminium, magnesium. Next substance after magnesium is copper, nickel. Okay, after copper we have the nickel and we have the iron. So these are the substances which have created the surface of the earth. Now interior of the earth. Now guys, these liquids, they were in the liquid stage. They all were in the liquid state or the liquid stage. So guys, they all are the immiscible liquids. They all are the immiscible liquid. Now guys, they do not get mixed with each other. So they show the process of sedimentation. They show the process of sedimentation. They show the process of sedimentation and they are the immiscible liquids. They do not get mixed with each other. So the densest substance, the substance which is having the highest density will at the lowest point and the substance which is having the lowest density will be at the top. Here we have the lowest density at the top and here we have the highest density at the bottom. We had drawn a concentric circle. Okay, so let's draw a concentric circle because this is very important for our exam point of. The substance which is having the highest density will be at the lowest point and the substance which is having the highest density among them is the iron. So iron will be at the center. So first we will draw the lowest density object. The substance which is having the lowest density will be the aluminium, will be the silica. Silica is the only non-metal. All are the metal. They all are the metal. And silica is the only non-metal. Okay. Now guys, after this we have the next circle and that particular circle will be of the next thing, that is the aluminium. After aluminium we have the next one, the major circle, and that will be of the magnesium. that concentric circle will of the magnesium. This one. This will be the magnesium. After magnesium, we have the next concentric circle, and that particular concentric circle will be of what? That particular concentric circle, the density will be of the, after magnesium will be the copper. Okay, and after copper we have after copper, what would we have? After copper we have the nickel. Okay, after copper we have the nickel. Okay, this would be the nickel. This would be the nickel. And guys, after nickel we have the next concentric circle, that is the iron, because iron is having the highest density. And after iron we have the second highest of nickel, third is of copper, next is of magnesium, aluminium, and the lowest density would be of silica. And remember one thing, silica is the only non-metal among them. Now what would happen, guys? After this, this is the center of the earth. This is the center. But this is the center of the earth. From center till the surface, earth is losing its heat. Earth is doing the process of radiation. The maximum heat loss will be from the surface. Maximum heat loss was from the surface, and the minimum heat loss will from the center of the earth. Okay, so are we good about these particular thing? Are we good about these points, guys? Now, after this, the earth was showing the heat loss, and due to this, guys, if we have any metal or we have non-metal, if we provide heat to them, they will expand. When we cool them down, then they will contract. So earth was doing the process of radiation. Earth was in its cooling phase. So they all will get contracted. But non-metals expand very fast than the metal, and they contract very fast than non-metal. So the expansion of the non-metal would be the very in wider sense, and the contraction will also be in the very early. So due to this, the silica that is at the top will get converted into the 1/3 of its original size, and there the aluminium will expose over the surface. So silica would be the 1/3 of its original size. The size of silica would be like this. Just wait, give me a minute. The size of silica would be like this. This should be the original size of silica. Silica will contract because there will be the process of radiation, and due to the process of radiation, silica will get converted into its original size. Okay, and aluminium will expose to the surface. This is silica. Okay, and aluminium will expose to the surface. And remember one thing, the earth was doing the process of radiation. Now guys, when I talked about the atmosphere at that particular time, I have to tell you one thing, that the composition of atmosphere. What is the composition of atmosphere? This is the process of radiation. When we talk about the composition of atmosphere, just wait. Okay, this was the formation of atmosphere. Now, guys, when we talk about the composition of atmosphere, nitrogen, we have to compare the original atmospheric composition till the with the present composition of the atmosphere. We have the nitrogen, that is N2. We have original and we have the present composition. Guys, when we talk about the original composition of nitrogen is 78%, and present composition is also 78%. When we talk about the composition of oxygen, the composition of oxygen at present is around 21%. Oxygen at present it is 21%, but the original composition of oxygen was 8%. Same with water vapor. Water vapor is in present time, it is in traces, but originally water vapor was 10%. Originally it was in a huge amount. 10% is not a less amount any day. So water vapor is 10% majorly. Next, when we talk about carbon dioxide, originally carbon dioxide was somewhere around 5%, and now carbon dioxide is 0.04%. Now guys, when earth was doing the process of radiation, at that particular time the water vapor get condensed. And due to the condensation of the water vapor, there would be the formation of the clouds, and due to the formation of the clouds for the millions of years ago, there would be the precipitation, and this precipitation will took place around millions of years ago. Precipitation will took place, guys, around millions of years ago. Okay. Okay. Precipitation will took place for around millions of years ago. This precipitation took place around millions of years ago. So after this particular thing, how our earth will look like? After this thing, the earth will look like, I'm showing you the side view. Let's see the side view. Let's see the side view. Okay, this is the earth's surface, and over this is the aluminium. Over the aluminium, this is the silica, Si, and all around the silica there is the presence of water. All around silica, like this. Okay guys, now what? Now guys, the thickness of this silica is 3,500 meters. Okay, this is the lower crust, lower crust, and this is the upper crust. Okay, due to the water vapor, uh, we have the due to the presence of the precipitation, we have the formation of oceanic water. Okay, now guys, let me draw a top view also. This is the side view. Let me draw the top view. How top view look like? Top view. So here we have the silica, and silica is known as the Pangea. Pangea. And here we have the oceanic water all around the silica. Okay, all around the silica. And this particular water body is known as Panthalassa. Panthalassa. Now remember, Pangea is a super continent. Pangea is the supercontinent. Panthalassa is the super ocean. Now the question is there. Now we have to talk about the certain thing that from here, how we have achieved our present world map. So the next topic of discussion would be the formation of present world map. Okay, so I hope you people enjoyed this lecture. So this is all for today, guys. Thank you so much. So please let me know in the comment section how do you what you feel about this particular lecture. So we have talked about a lot many things in this particular section. Okay, so this is all for today, guys. Bye bye and Jai Hind. Thank you so much, and don't forget to continue your current affair class till tomorrow at 7 a.m. in the morning. Okay, so bye bye, thank you, and Jai Hind. Thank you so much. Bye.